So now that we did our first transaction in the previous video, which was this transaction right here, we did this transaction only using Eternal. We will try to get started to recreate a transaction with a similar structure. So the objective of this transaction, if you remember, was to send 10 ADA to Bob. Now that we did this with Eternal, we will try to create our own transaction using only some Typescript. And in order to do that, of course, we will be using plu-ts. Now, I have set up a repository for this documentation course that will be updated with all the following videos and projects that we are going to do. And if you go look at it, it is very likely that there are more subfolders here. But here, as you see, we have already the part 1 folder. And of course, the link to this repository is in the description. So you can go and check this repository from there. Or you can also reach this repository if you have already the link to the plu-ts documentation, which of course is plu-ts.armoryclubs.tech. You'll see here that there is the GitHub. This will bring you to the GitHub of plu-ts, which is under the Harmonic Laboratories organization. So you can go check the repositories of the Harmonic Laboratories, and eventually you will find Cardano TS Beginner to Advanced, which is the repository of this documentation course. So as I was saying, here we have the part 1, there is a simple transaction, and there is a setup folder with a package.json with some dependencies that are already here, and we'll see what they do in a moment. Some TS config, so that we can compile here by running npm run build, so the Typescript compiler. And yeah, and there is an initial index, which is our main, where we have some initial code from which we will start to build our first transaction to send 10 ADA to Bob. So to begin, you just have to copy this link that you find if you go to the repository of the documentation. You will find here a green button with code, and this button will pop up a link that you can copy, and with that link you can open your terminal, navigate to the path that you want to have your project in. So as an example, I will go in H Labs, and then you can just run git clone, and then you just paste it here. I do already have this repository, so I'm not going to run this. And once you have cloned this repository, you want to open the project with your editor of choice. And here we see that we have the exact same project, well, with some more folders. But if, as said, we navigate to the part 1, and in the simple project, you will have setup folder, and you will also have a final folder. The setup is the folder that you can modify to follow along and try to build yourself your transaction. And I would suggest for you to do that, because it is really instructive, and it will help you if you have no knowledge prior regarding blockchain in general. So we will build a simple transaction here. And this is the basics for all the future more complex transactions. So I will really suggest you to take your setup folder and modify it as we go through the final folder. We see to see how the final transaction looks like. So here is the SRC folder, and as I was saying, it has already some dependencies. These dependencies, the most important one is of course yes, because plu-ts is what we are using to, in this case, build transactions. We also have blockfrost plu-ts, which is the integration or the blockfrost service, which will allow us to essentially have a connection to a Cardano node, and this Cardano node will give us the information that is on the blockchain, such as the utxos or the address, and will also allow us to submit the transaction. And we have some other utilities, as you see here. These are not really important. And we have BIP39. BIP39 is the standard from Bitcoin that allows us to take a seed phrase and get our private key. We'll see how this is done. And since we are using the private key, you generally don't want to share your private key to the world. So we will keep that private key secret, setting an environment file that is never pushed to the internet. but in order for the environment file to be loaded in the code, we will need also .env. So if we go take a look at the index.ts to see how these dependencies are used, as I was saying, the first call is the config function from .env. All this function is doing is looking for a file that is called .env, like this. Here, you create a new file and you call it .env. And this file, as you see, is grayed out because it is never pushed to GitHub. And this file will contain sensitive information such as the seed phrase or the API key to access the block processor. So those secrets you generally don't want to share in your to the internet. So what we are going to do is create an environment file called like this .env, quite literally. And then the first thing that we are going to write in this file is the name of the variables. So as we saw, we need that seed phrase, and we set an equal, and we use a quote. And here you are going to write your seed phrase that if you want to be compatible with Eternal, there should be the seed phrase of your wallet that we set it up in the previous video. And the other secret that we will need, as I mentioned before, we will be using Blockfrost. Blockfrost is a service, and as a service, it requires an API key to access the endpoint. So we will set here a Blockfrost API key. And now, in order to get your Blockfrost API key, you will have to, of course, search for blockfrost.io. If you want, here there is some documentation on how Blockfrost works. There is also an Open API specification. However, we will not need this because here Blockfrost plu-ts already wraps that specification for us to use directly. So what we want to do is directly click here on Start Building, and this will then ask you for your email or eventually some Google or whatever you prefer to log in and set up an account. Once you have set up an account, we will need to create a new Blockfrost project, and that Blockfrost project, when you create it, please make sure to select the pre-prod network. As you remember, we are here in the pre-prod and not on the Cardano mainnet, not on the preview, but on the pre-prod. This is really important, otherwise your Blockfrost will not work. So once you have set it up your project, the API key will be shown to you. And once you have your API key, you can go back here in the project, open your .env file, and paste here your API. If you have created the API key correctly, the API key of Blockfrost will start with pre-prod. This is really important. Then will be a bunch of garbage here. Make sure that you populate this environment. And once you have completed the .env file with your seed phrase and your API key, we will have everything we need to start working on the project. Now, before we start properly, let's see what we have here as the code already. We have a bunch of import. We have the config call that is loading the environment variable from the .env, and then we have our main function. The main function, the first thing that does is takes the seed phrase, pulls the mnemonic to entropy from BIP39. So it's taking those words and essentially spitting out a bunch of bytes, buffer, that is then passed to XPRV from entropy. So XPRV is short for extended private key. That is what your seed phrase will give you. And to be clear, this is not your actual private key to sign, and we will see later why, but it is actually the root of all your possible private key. The important part here is that we are actually getting something that will allow us to have our private key later. Using this root, we can pass the root directly to address from XPRV. Address from XPRV expects the root and the network that we're working in. If you do not pass anything, it will be mainnet, but we are not working mainnet. It only cares if it is mainnet or not, essentially. So we can just specify testnet, and it doesn't really care if it is preview or other, but it is really important that we specify it. And from its XPRV will automatically derive the default address. As mentioned before, you could have multiple addresses. That is also why I told you when we set up the wallet in the previous video, that is preferred if you can choose to only use one account, because otherwise you would have different derivation. And as you see here, if you have selected more than one account, this is the derivation path that is being used to get that specific address. Actually, to be precise, the payment part, that address, so that is only half. And the second part you will find here. This is the derivation path for this stake address. We'll see what this derivation path is in a second. But if you have used only one account, then you should have the default address, which is what we get here by calling address from XPR. So this should be, in theory, if everything went correctly, the address that we have over here on Eternal. So to check that this is the case, we will need to run this code, because at the end of this code, we are making a call to console log to address, where address is the address that we got from our seed phrase. So in order to call this code, first of all, you will need to install the dependency. As for now, you do not have a node modules in your folder. So what you will need to do, since we have specified all the dependencies here on the package.json, all you need to do is just call npm I, which is sure, I'm sure you know, to npm install, or you can also, if you want to really be sure, npm install. So running this npm install, you will see that you now have these node modules in your folder, and that means that we can run this code over here and see what address has been derived from this. So if we now run npm run start, which is really just going here in the script, looking what start does, and in this case it calls that npm run build. So it builds the project, calls the Typescript compiler, and then calls node with this.index.js. So if we run it, you will see that it is compiled Typescript. Once it is finished, you have a this here, and this as a this index, which is the JavaScript file. Oops, yes, I do not have this phrase here. I will have to use instead my final. If you have not set up your seed phrase, this is what you will get. So let me move to the final and modify accordingly. Okay, and now that we are in the final, which is where I set it up my seed phrase, we can go ahead and npm run start here. So here we have our seed phrase of the Eternal wallet that we have over here. Yes, and exactly what has happened is that we have derived the private key, derived the address, and we are showing the address. And if we look here, the address that we got here is exactly the same of this address here. So that means that everything seems to work properly. So the first step to build a transaction is to get our utxos. If you remember here, when we built a transaction to send data using only Eternal, we first had a look at the utxo list, and this is what we had. So in order to get the same information here on our code, we will need to access the node. So in order to access the Cardano node, we are using Blockfrost as a service. So we'll go ahead and create a Blockfrost instance. To create a Blockfrost instance, you can import from Blockfrost plu-ts this Blockfrost plu-ts class, and it expects a bunch of arguments, but the only one really needed is the project ID, which is nothing else than your API key that you have in your environment file. So we have that API key in the .env file if you have set it up correctly. So now we have a Blockfrost instance that will allow us to access data from the Cardano. In our case, what we want is to access our utxos that are under our address control. So in order to do that, we will make a call to blockprost and call the address.utxos method. The address utxos method that expects an address, of course, in order to query the Cardano node. So we are passing our address, which is what Eternal was using here, as we just saw a second ago. And this will return a bunch of utxos with some additional information that we don't really need. We just need to know that those are utxos. In order to show those utxos, we can console log here, and we are not directly console passing the utxos because those are classes, might be slightly hard to read. We are serializing them as JSON and then passing the result to JSON.py. So if we run this code now, we should be able to see some. Oh, sorry, I need to save the file, otherwise it doesn't know that we are trying to search for it. So save the file, then run npm run start. So now we should be able to see what utxos are under our, and indeed we do receive something more time. So we have still our address, and we see that we have a bunch of utxos over here. If we go look at Eternal here, these are the utxos that we should expect with well, at least for me, for you will be slightly different. And indeed, we see that we have some utxos that starts with this transaction hash, as we saw, and the index number 2. So in this case, this is the utxo that is shown to us. These other utxo are the number 3. And what information is on the utxo is that, of course, the utxo ref, but we also have some other information. The result field on the utxo is the actual data created from the transaction output of the transaction that generated. So the most basic information that you will ever found on an utxo is the address and what value is associated with that utxo. So the address is, of course, since we queried by address, we should expect this address to be our own, and the value is kind of nested. We'll see why it is nested, but we can see here that it has some empty string, which we can interpret as the default asset of the Cardano network. And of course, the default asset of the Cardano network is ADA. And here we have some big number, which is an integer. If we go back at the terminal, we'll see that the utxo that we're looking at is this one, and it is telling us that it has 2,000 and something ADA, whereas here we have much bigger number. Why is that? Because this is not actually ADA, rather are Loveless. Loveless is the smallest unit of measure for ADA. 1 million Lovelesses is actually only 1 ADA. So if you see this big number here, actually these are decimals if you look at it from the point of view of ADA and not Lovelesses. And what we have here is indeed the same amount that we see over here. So this is the information that we have on utxo, and we can use this information to build our. So let me go ahead and comment out the code. And the next thing that we want to do is, of course, to build the transaction. In order to build the transaction, we will need a transaction builder. Transaction builder is a nice interface that plu-ts exports. So you can go in the plu-ts documentation if you want to know more, and you can check for the off-chains. We are just creating transactions here, and the off-chain will have this transaction builder API. Transaction builder API has a bunch of information, but the main method that we are interested in is build sync. Build sync is what will really allow us to build a transaction. So before we have a look at the build sync, let's go back to the transaction builder. We see that the transaction builder expects some protocol parameters in order to work properly, and eventually, if you want, some genesis infos to some information that is rarely accessed but may turn useful. Anyway, we will need only the protocol parameters for this simple transaction. So in order to get the protocol parameter and to build a builder, to of course construct a new transaction builder and get the protocol parameters from block, we can do that by, well, calling blockprost dot get protocol parameters. This is a promise, so we want to await that, and that will give us our transaction builder. Transaction builder, as said a moment ago, we can use to construct a transaction, and we will see what we are doing here in a second. As said before, we are using the build sync. The build sync method is doing a bunch of stuff. So if we go look at the documentation, it can take a lot of arguments. The only required one is input by this interface, but in reality, we need to specify either the change address or the change with some additional information. If we don't, transaction builder cannot build a transaction because it needs to balance the value in the input and in the output. The output are also optional, but most of the time you will need to specify to build your transaction properly. Because as we will see in a second, we need to specify some inputs are nothing else than utxos. As we also saw in the previous video, we are using utxos as input, and we need to use all the value that is present on that utxo in order to send some value somewhere. For the purpose of this video, we are just blindly selecting the first utxo of our utxos under our own address as the only input of the transaction. So if we go look at the order in which these utxos were here, we know that we are using as total input around 2000 ADA. We are specifying the change address to be our own address, so whatever input is left after the transaction, it will be sent back to this address specified here. So in our case, it will be sent back to us. This is what the transaction builder is doing. It is adding an additional input, and we will see that in a bit. It is adding an additional input to the transaction that goes back to this address. The additional input, we do not specify the value, as we saw here, because the transaction builder needs first to calculate the transaction fee that we don't really know before we build our transaction. So the transaction builder will do exactly this, will balance the inputs and the outputs. And speaking of outputs, we will need to specify an output also here. So the output is also an array. As we saw, we can have multiple outputs of a same transaction, and the most basic information that you will need always to have on an output is the address to which the output belongs and the value that transaction out. Now, value can be complicated, so that is why it is a class here, but there is an utility static methods for a simple value that only adds add, and that is value.lovelasses. So value.lovelasses expects an integer with the amount of lovelasses that you want to associate with this particular output. And as you remember, 1 million lovelas is exactly only one ADA. So what we are setting here is the value of this transaction output to be 10 ADA, and we want to send it to Bob. We need to get the address of Bob. We did get our address before from the seed phrase, but we don't really need to do this. In order to get the address of Bob, we can simply call address.from string that method. The address from string expects a string. I have already copied here the address of Bob. So to get the address of who you want to send, you click here, and you can see that this address is what I have copied right here. Okay, so now we have the Bob address. The reason we did this before is because we will need to sign the transaction, and in order to sign the transaction, we need the private key. But we could have done exactly this also if we only needed the address, which is our case with the Bob address. So with this, our transaction is kind of complete. It is missing another step that we will see in a moment. But first, before continuing, let's try to see what is the structure of this transaction. So let me go ahead and clear the terminal, save these files. So this is what we have. Oh, actually, first I need to add the console node, and here we have it. We are showing to the output of the terminal the JSON of equivalent of this. So now that we have saved the file, we can run once again npm run start. Now we'll do all it did before, but this time will show us the transaction that we have just built. And indeed, here we have it. We have one input as specified, which is exactly what we are expecting here. We have two outputs, even though we only specified one single output to go to Bob. However, the transaction builder added a second output to our own address. If you look, this is the same address as the input, and this is instead the address of Bob that we have here. What will happen with this transaction is that this input will be consumed. It will no longer be valid because, of course, it was an unspent transaction output. The moment we spend it, is no longer a spend. So this will no longer be a valid input, and it will create, so it will consume this, and it will create this value on the other side. And the transaction builder also has calculated the lowest possible fee for this transaction for it to be accepted. It doesn't make sense to increase this fee unlike other ecosystems because there will be no priority. So this is the best you can get for the fee, and this fee has been subtracted essentially to this output, which is going back to the change. So this is our transaction. What we're seeing here is that we are missing some witnesses. That means that this transaction is not yet signed. So if we try to submit this transaction as is, it will not be accepted by the Cardano node because we have not signed it. In order to sign this transaction, we can simply call transaction the transaction.signWith method like this, and transaction sign with expects a private key. So we have a private key, but as I mentioned at the beginning, this is not the actual private key of this address. The private key is derived following this path, and so we will need to derive ourselves our own private key following that exact path. So we go ahead and derive the private key from our root. This is the path as we have here for our own address. So this is the actual private key that we will need to pass here. If we look, we have the root here that we got at the beginning through the seed phrase, and we are specifying the path. When you see this apostrophe, you need to use this harden function before passing to derive. It will only actually set a bit to signal the derivation function that you want to follow this path. It is just slightly different, but it's really important. Then we are passing these others here. We are passing these others here, and then we have 0, 0, so here. And this is our final private key. Then we expect either a normal private key or an extended private key, so we are good with this. And now that we have cool transaction sign with, we will still see what is the result of this. So if we go back here and first of all clear and then npm run start once again, we should see the same transaction, but now we should have some signature. Let's see. Okay. Yes, and indeed this is the same transaction with the same input, the same output, the same fee. But now we have some BK with BK is another way to call the public key. So this is the public key corresponding to my private key, and this is the signature of the transaction body hash to be clear. Now this transaction is signed, and since it is signed, that means that we can finally submit our transaction. To submit the transaction to the network, we will of course need to have access to a Cardano node. We are using BlockFrost, so we go ahead and call this BlockFrost.submit transaction, and we pass our signed transaction over here. This is a promise once again, so we will await this, and as soon as the transaction has been submitted to BlockFrost, we will show in the console the hash. We could show it also before, but we want to make sure first to submit it. So we go ahead, clear, save the file, and see if the transaction is submitted correctly. We call the program. And yes, we get back our transaction hash. We can copy this hash and we can go over to the Cardano Explorer. In our case, we'll go to cardanoscan.io. Make sure to go to the pre-prod version of Cardano Scan. Here you will be able to paste your transaction hash. And if you do that, oh, okay, this transaction was pretty fast, so we already have it. You may find somewhat an error that says, okay, we have not found your transaction. If you got your hash from submitting this transaction to BlockFrost, you do not have to worry. Maybe you need to wait at most 1 minute. It really depends on the network. Anyway, we see that this transaction has been accepted to the network, and we are able, since we have used the same address of Eternal, we should be able to see this same transaction here. In fact, we see that Bob has now 10 more ADA, and we see that our wallet has 10 ADA less minus some fee. This is indeed the transaction that we built, a single input and 2 outputs, and only the fee. So this looks all good. We have successfully built and sent a transaction only using our own program. So this is the final version of this simple transaction project. And in the next video, we will go ahead and try to look better what is on a UTXO and on a resolved UTXO. So we will get more familiarity with the UTXOs of Cardano.